Comet was commissioned in 2017. This 10,000 square foot facility significantly enhanced NREL's composite manufacturing capabilities and allows researchers and engineers to design and prototype composite structures and structurally validate them all in one location.
Comet was created to research the science of scaling for composite materials and manufacturing. Basically, how do we go from benchtop success to really large structures such as wind turbine blades? Comet enables us to address all of those scaling issues, from small coupon scale articles in the laboratory up to very large composite structures.
Additionally, this is an education facility. We've brought groups of students, groups of stakeholders in here to demonstrate and show them how we're able to use these new composite technologies and then evaluate the end component to make sure that it works the way you need to.
Over the years, we've built capabilities here at the Comet to address research needs for composites materials and manufacturing. And that includes both our human resources and our capabilities through equipment. The equipment here varies from very small to very large as we approach research at scale. Things like glass tables and vacuum pumps and Eastman cutters enable us to efficiently perform research in the area of composite materials.
One of the great things about the Comet is the size of the facility and the size of the projects we are able to undertake.
We work with both private and public organizations, whether it be universities, national laboratories, or our industry partners. Basically, it allows us to all come together in a single space here at the Comet and work side by side on challenging problems in the areas of composite materials and manufacturing.
A great example of that is the recent work that we did where we built a 13-meter blade in collaboration with the IACME Institute, and we're able to not only build the entire blade in this facility, but we're also able to walk across the street, put it in our structural test facility, and validate it as it went through a bunch of dynamic transitions to show that the material was resilient enough to operate in real conditions.
Comet is helping make wind energy and water power more cost competitive and contributing to better recyclability of the blades for both wind energy and water power.
But we can also play a critical role in other applications, things like vehicles technology, buildings, energy efficiency in aerospace, and other applications for composites. As we expand into these other research areas, we'll have an opportunity to impact the factories of the future, whether we're performing research in automation at scale, sustainability, or circular economy. Will help to enable U.S. manufacturing to be more competitive and more energy efficient.
We have the capability here to be able to integrate automation. How do you automate that full process? How do you build what goes onto this structure in order to attach it to a hub in a wind turbine blade? You could look at the alignment of the bolts. You can look at finishing processes that go into actually completing the blade itself. And we have all those capabilities here. We just need to bring them in, and over time we'll be able to help the automation industry in doing that.
The Comet facility has been a great success, and it will continue to be a place where we can gather side by side with industry partners, universities, and other national labs in order to advance composites manufacturing and materials research.
We haven't tapped all the potential that's in this facility yet, and as we continue to do research, look at the science, and then look at how it can be applied at a larger scale, this facility is ripe for that kind of work, and we're excited for the future.